Welcome to Chibuzor Math Physics. In today's video, we are going through the eigenvalues and eigenvectors. And this would come to your mind if you are doing linear algebra. So in linear algebra, actually an eigenvector or what we call the characteristics vector of a linear transformation, they are regarded as a non-zero vector that changes at most by a scalar factor that we will talk about in a short while. Of course, that scalar factor is referred to lambda because lambda is often associated in order to find the eigenvalues and the eigenvectors. So in order to determine the eigenvector of a matrix, the first thing you must do is to determine the eigenvalues. Substitute one eigenvalue, which is lambda, into the equation so that you are able to compute the eigenvectors corresponding to each of the eigenvalues. So let me show you the definition of what we mean when we talk about the eigenvectors and the eigenvalues. So we said that let A be an n by n matrix. So the number lambda is an eigenvalue of A if there exists a non-zero vector V such that AV is equals to lambda V. So when we compute this, we will end up with, let's take a pen. If we compute this, we will end up with the equation. We will end up with the equation determinant will be equal to, let's say, A minus lambda I, and this must be equal to 0. Of course, what we are referring to here, A is a square matrix because this matrix must be in the form of a square. Lambda is going to be some scalar quantity, and I is just an identity matrix that we are going to be using in this computations. So let's take an example, and maybe you are going to understand this more better. I remain your friend, Augustine Galagash. So the first question, we are to find the eigenvalues and the corresponding eigenvectors of this matrix. A is given by 0, -2, 1 and 3. So let's take the solution to this. The first thing we need to do, so let's have a solution. The first thing we need to do is to write our equation. It is given by A minus lambda I, and we know that this we are looking for the determinant of this. So this would be equal to writing down this matrix that we are given here. We will have 0, 1, -2, then we have 3. This is the matrix that we are going to find the determinant, but then minus we have lambda, and the identity matrix for this 2 by 2 matrix would be 1, 0, 0, 1. This is the identity matrix, and all these must be equal to 0. This is the first thing that we need to do. So going further from here, we simply need to multiply this lambda, which is a scalar, to this identity matrix as it is indicated here. We are supposed to let me use a different color. You see here, we are supposed to multiply scalar by this unidentity matrix. So when we do that, we will simply have lambda multiplied by 1 here will give us lambda. Lambda multiplied by 0 would be 0. Lambda multiplied by 0 will be 0, and lambda multiplied by 1 will simply be lambda. So this is what we are going to have here. So it will therefore means that our matrix now, we simply take this to minus lambda. So 0 minus lambda, we will simply have minus lambda. So let's have that here. this will be minus lambda. We have 1 minus 0, this will be 1, we have 1, and we have negative 2 minus 0, we will have 0, we have negative 2, sorry for that. This will be negative 2, and then 3 minus lambda. Here we will simply have 3 minus lambda. So this is what we are going to have as we find the determinant. At this point we find the determinant for this, and you know the way to find determinant. You simply multiply this lambda. Let's have lambda. Remember that in our, when we are looking for instance, if you are looking for determinant, this is positive and this is negative, so don't forget that. But we are having negative here, so let's have negative lambda. Multiply this by 3 minus lambda, 3 minus lambda, minus, we have 1, because of this minus sign here, minus 1 into we have negative 2, because we are looking for this negative 2. We are looking for the determinant of this, and all this must be equal to 0 like we indicated here. If we simplify, you will simply have negative lambda by 3 will give us negative 3 lambda, negative 3 lambda plus negative lambda multiplied by negative lambda will give us a positive lambda squared, and we also have negative 1 multiplied by this will be positive 2, and this will be equal to 0. So now solving for lambda, but before then let's try to rewrite this. We simply have lambda squared minus 3 lambda plus 2 is equal to 0. So our lambda, you can even use your calculator or you try to solve for lambda, will be equals to lambda 1 will be equals to 1, and then lambda 2 will be equals to 2. That is if you solve for lambda. This is lambda squared plus 3 lambda plus 2. This is plus 2, just a minute. Plus 2 is equal to 0. So our lambda 1 is simply 1 and our lambda 2 is simply 2. So at this point we are going to now replace the eigenvalues. So these are our eigenvalues. Just a minute. These are our eigenvalues. So our eigenvalues, lambda 1 is 1 and lambda 2 is simply 2. This is our eigenvalues. So we are going to use these eigenvalues to find the eigenvectors corresponding to lambda 1 and lambda 2. So let's do that. So here we have first lambda 1 is equals to 1. So solving for the eigenvectors, let's replace lambda. Let's replace 1 where we have lambda. So here we will have negative 1. This will be negative 1. Negative, let's have that down. Simply have negative 1. We'll have negative 2 because we have 2 here. We still have 1 here, so this is 1 and this is 2. This is how we compute this. So now this will be let's introduce some arbitrary C1 and then C2, C1, C2, and this must be equal to 0, 0. Good, must be equal to 0, 0. When we need to solve for C1 and C2, simply say that negative C1 plus C2 is equals to 0 because we have negative C1, this is our C1 and this is C2, so this will give us 0. Here we have negative 2C1 plus 2C2, and this is also equals to 0. So it therefore means that C1 is equals to C2 because if you look for C1 for instance, here let me take a different color to show you what I have done. Let's say that we have 2c2 because this is 2c2, and this is equals to, take this negative the other side, it becomes positive 2c1. So divide by 2, so it simply means that c2 is equals to c1, so c1 is equals to c2, and this will becomes our x1. So x1 is equal to c1 and c2. x1 is equal to c1 c2, which is equals to separating c1, we will simply say that c1 is equals to 1 1. So this is our x1 in terms of the eigenvector. So now let us replace lambda 2 and find our x2, which is corresponding to eigenvectors. Let's do that. Let me get rid of some of these. So now replacing our lambda 2 is equals to 2, replacing that into this equation, we have negative 2, we have negative 2, this is negative 2, this will becomes 1, we have 1, we have negative 2, when we have 3 minus 2 becomes 1, 3 minus 2 here becomes 1. So we simply replace 2 where there is lambda in this first matrix, so that now we can find C3 and C4 having introduced C1 C2. So let's say that this is C3 and C4. So C3 will be this will be 2C3. This is negative, so it is negative 2C3 plus C4, and this will be equal to 0. It is the same because this is 2 here and this is negative 2, negative 2, so one equation is enough. So this means that C4 will be equals to 2C3. C4 will be equals to 2C3. Let's get rid of this. So now if C4 is equals to 2C3, our x2 therefore would be equal to C3, and then we have 2C3, because that is what we have here. C3, we have C4 and 2C3, so C3 to C3. Separating this, we will simply have our x2 to be equals to, we have 1 here and this is 2, and this is how we find eigenvalues and eigenvectors. I hope you have enjoyed the video. You have to go step by step when you are dealing with the eigenvalues and eigenvectors. The first thing you need to do is introduce the equation, and when you introduce the equation you need to multiply it with the scalar, which is lambda, then minus take the square matrix minus the scalar that we have already multiplied with the identity matrix, and that will lead us to finding the determinant. And after we've got the determinant of these matrices, we can now use the eigenvalues which we got from the determinant, because the determinant we are going to get lambda 1 and lambda 2, which are the eigenvalues. So those eigenvalues will be corresponding to some lambda 1 and 2 respectively, and then we replace those values with those lambda, and then we are able to find the x1, x2, x3, x4, which are those are the eigenvectors. I hope you have enjoyed the video. In the next video we are going to introduce 3 by 3 matrices where we are required to find the eigenvalues and the eigenvectors respectively. I remain your friend Augustine Galagash, and if you are joining us, click on the subscribe button so that you'll be notified as we upload our subsequent videos. Thank you and God bless you.